Hello, these are going to be the first part of the section 9.2 notes on ionic compounds, being able to write their names and their formulas. And this part is going to be on binary ionic compounds. All right, so the learning goals for section 9.2 are apply the rules for naming and writing formulas for binary ionic compounds. We'll cover that one here today. The next one is apply the rules for naming and writing formulas for compounds with polyatomic ions. This is going to be covered in the next section of notes. All right, so it'll be 9.2, the second part of that. So we're not going to cover that today. And then recognize when to use Roman numerals and parentheses when working with ionic compounds. So today we're not going to use parentheses, but we're going to look at using Roman numerals, which you learned about in section 1. And then determine the charge of an ion based on the formula of an ionic compound. Okay, so a binary ionic formula. So with a binary ionic formula, it's going to be a metal and a non-metal. Okay, so this is the situation where you're given the name of this ionic compound, and we have to write the chemical formula. So we're going to use their chemical symbols from the periodic table. All right, now the main thing with this, when we write out the formula for this binary ionic formula, the charges have to add up to 0. So the positive charges have to cancel out the negative charges. So if we need more than one of a particular ion to cancel out the charge, then we show that with a subscript, like the 2 in H2O. That's a subscript. That's going to show how many of each ion that we have. When you write out the formula, we always write the positive ion first, the negative ion goes second. Couple things that don't show up in these formulas: you don't show the charges of the ions, and you don't show any Roman numerals. The only numbers that would show up would be the subscripts, which show the number of each ion. All right, so here's a couple of examples I want to work through, and then before I have you try this out, this calcium fluoride and this cobalt-3 sulfide. Okay, so I switched over to this Jamboard to work through these examples, okay? So the first one, we got calcium fluoride. The second one will be cobalt, the Roman numeral 3 sulfide, okay? Now we have to be able to determine the charges of these ions to write out the chemical formulas. So the way we do that, there's a couple different ways. We can use our periodic table, and with our periodic table, we've talked about charges before. It's in this first column, the alkali metals, they're all going to be positive 1s. The second column, the alkaline earth metals, those are going to be positive 2s. Over here you got aluminum, that's going to be a positive 3. So those are that's one way you can figure out the charge of the ion, is by looking at the column that element comes from on the periodic table. Another way is if you're given a Roman numeral, the Roman numeral is going to indicate the charge. All right, so there's also a list of ions. This is the positive ion list that's on the back of your periodic table. So this will give you the charge of a lot of the positive ions, and then these are the Roman numerals that you need to know about. So chromium can be positive 2 or positive 3, and that's indicated with the Roman numeral. You have cobalt, can be positive 2 or positive 3. Copper can be positive 1 or positive 2. You have iron, which is right up here. That can be positive 2 or positive 3. Lead could be positive 2 or positive 4. And then you have manganese right here, and mercury, and it shows the different charges. And then you also have tin. Okay, now most of these are transition metals in that D block of the periodic table, but there's also lead and tin, which is to the lower right. It's in the representative elements, but they can form some different charges. They do different things with their valence electrons. All right, but if you see a Roman numeral, that's going to tell you what the charge is. Okay, so a lot of those elements that have Roman numerals, like iron, cobalt, copper, a lot of those elements are in this center, the transition elements right here. But like I said, we also have tin and lead, which are right down there. Okay, so that's the first thing we have to do. To be able to write these formulas, we need to know how to determine the positive charge and the negative charge on those ions. Okay, so going back here, we have calcium fluoride. Okay, so calcium is right here on our periodic table. It's in the column that forms positive 2 ions. And then we have fluoride. Fluoride is, going back to the periodic table, it's one of these halogens. The halogens form negative 1 ions. Okay, so we've determined the charge on each one of those. So we have calcium forms a positive 2. Fluoride forms a negative 1. So we have to make the charges add up to 0. Okay, so you want to think how many of each ion you need to cancel out the charge. So with this situation, you would need 2 fluorides to cancel out the charge of calcium. So that means, and we show that with subscripts. So we'd write CaF2 to show that we need 2 fluoride ions to cancel out the charge of the calcium. Another way to look at this, if you take the magnitude of the charge, the number, if you cross that over to the subscript of the other ion, then those charges will cancel out. We just don't write ones though. So it'd be 1 calcium for every 2 fluorines. So you can do this crossover method. The only thing you have to worry about with this, if you can reduce the subscripts, then you have to. For example, if we had 2 and 2, you would have to reduce that down to just 1s. Or like 2 and 4, you'd have to reduce it down to 1 and 2. All right. So that crossover thing works every time. Just make sure it's in the lowest possible ratio. Okay, now for cobalt 3 sulfide, so with the Roman numeral 3, that tells you that cobalt is going to have a positive 3 charge. Okay, the Roman numeral tells you what the charge is for the positive ions. Sulfide, that's in the column. Let me show you on the periodic table. That's in the column right here that forms negative 2 ions. Okay, it's also in the ion list on the back of your periodic table. Okay, so we have a positive 3 and a negative 2. So you think a common multiple between those would be 6. That means we'd have to have 2 cobalts for every 3 sulfides to get the charges to add up to 0. So we get a positive 6 and a negative 6. You can also, just like the other example, you can take the magnitude of the charge and cross it over to the other ion, and it becomes their subscript. So CO2S3. So those are the 2 examples right there. Okay, now going back to the slideshow, there's some 5 practice problems. So go ahead and pause the video and try those out. And here are the answers for those 5. Magnesium is a positive 2, chloride's a negative 1, so you need MgCl2. K2S for potassium sulfide. Copper, Roman numeral 1, so it's positive 1, nitride's a negative 3. Iron, positive 3, oxide's a negative 2, so it's Fe2O3. And then this is strontium sulfide. Okay, now going the other direction. So this is when you're given the chemical formula for this ionic compound and we have to write the name, okay? So these are the things to think about when we're doing that. We always want to write the positive ion first. Positive first, negative second. And then we just want to name the ions. But the negative ion is going to have an "ide" ending. So like chlorine becomes chloride. Roman numerals are in the name if they're needed. And they're needed if it's a transition metal that's on that list of ions that have Roman numerals, like copper or lead. Those elements need Roman numerals to distinguish between the different charges that they can form. We don't indicate a subscript in the name, so we just name the ions. Okay, so for example, I got MgBr2 and PbS2. Okay, so I went back to the Jamboard here so I can type these out. So these are the two examples, MgBr2 and PbS2. Okay, so the thing to consider is really we just have to look at the positive ion and determine if it needs a Roman numeral, okay? And the way we do that, you can look at this list of ions right here, okay? So if it has a Roman numeral on this positive ion list, then it needs to show up in the name, okay? So something like magnesium in our example, well, here's magnesium. It only forms positive 2 ions, so we don't need a Roman numeral for magnesium. So we can go back here. If magnesium doesn't need a Roman numeral, then you just simply have to name the ions. So we're just going to call this, type this in, maybe not quite so big though. There we go. Magnesium bromide. So we want an "-ide" ending, and we don't indicate anything with that subscript 2, as in you don't call it dibromide or anything like that. We just simply name the ions. The only thing we have to worry about, like I said, is do we need a Roman numeral or not? Okay, so now with PbS2, we want to look up lead. Okay, so going back to our list of ions, lead is right here. Okay, lead needs a Roman numeral. It can either be a positive 2 ion or a positive 4 ion. So then we have to determine, well, which one is it going to be? Well, you look and see, well, what is it bonded to? It's bonded to 2 of these sulfide ions. So sulfide is a negative 2 ion. Okay. Now there's 2 sulfides in the formula, so 2 of those negative 2's make it negative 4. So you got to think, well, what positive charge does lead need to cancel out the charge of that sulfide? Well, in this case, it's got to be positive 4. So we're going to show that with a Roman numeral 4. Okay. So again, to determine what the Roman numeral is, you look and see, well, what negative ion is it bonded to, and how positive does this have to be to cancel out the charge? So when we name this now, we're just going to type in lead, and then we need a Roman numeral, so we're going to put IV for 4, and then sulfide. Again, you don't indicate anything with that subscript 2, we just name the negative ion with an "-ide" ending. Okay, so those are the 2 examples right there. All right, so again, going back to the slideshow, those are those 2 examples. You can pause the video and try out these 5. I'll give you, you can take as much time as you need, and I'll show you the answers. And there they are. So with these examples, barium and aluminum do not need Roman numerals, so we're not going to include any. Copper, mercury, and iron need to have Roman numerals, so we have to indicate what the positive charge is. And then all these negative ions have "-ide" endings. All right, and that's all for the notes for that first section of part 2. So have a good day.